Hey everyone. So we have a lab coming up, and I wanted to take a little bit of time and explain how the lab's going to work and do a short demo for you. So here's how this is going to work. So the lab is on a fictional element called Beanium. Okay. And the purpose of this lab is to kind of see how atomic masses are calculated and how weighted averages are calculated. So to do that, we're going to use our fictional element, Beanium. Okay. So this is my sample of Beanium for this activity. Okay. So for this lab, what I'm going to do is first, step one, obtain a sample of Beanium. Got that. Okay. What I'm going to do is I'm going to take my sample. Okay. What I'm going to do is I'm going to separate this into my different isotopes of Beanium. Now, when you get your sample, what you're going to see is there are 4 different isotopes. Okay. So I'm going to point them out. This one right here, I'm going to call this isotope A. This one right here, I'm going to call that isotope B. And actually, let's rearrange it so it's a little bit more clear. So there's A, there's B. This one's going to be my isotope C. And this one, it's a little hard to see. Let me hold it up for you. This is my isotope D right here. Okay. So I'm going to separate my Beanium sample, that's all these right here, into my different isotopes. Okay. So you guys are going to get to see me kind of do this one in real time. Okay. There's my isotope A. My isotope B. Let's get the rest of that over there. Okay. Isotope C and D. I'm going to work on splitting those up. Now, some of these beans right here are a little small, so it's easy to lose some of them. So you got to be pretty careful when you're separating them out. Okay. Now, the important thing to remember is just like in real elements, okay, each of these isotopes is just a different version of the same element. Okay. So all of these are my element Beanium. They're just different versions of the same thing. Okay. So what I'm going to do now is I'm on step 3, right? I've separated them all. It's part of step 2. So step 3, I'm going to weigh each isotope individually. So my isotope A, I'm going to weigh it out. Okay. And I'm redoing this. So let me just clear out what I got. Okay. So I got a mass of 7.34. Okay. Now, on my chart right here, okay, this is my calculation spreadsheet. You're going to be using this to do your calculations as well. For my isotope A, next to total mass, I'm going to put the mass that my scale reads. That's 7.34. Okay. And I'm going to hit enter. All right. Next, isotope B. Okay. Now, it doesn't matter which letter you designate to which bean, as long as you're consistent. Okay. So these red ones right here are going to be my isotope B. I'm going to put 9.12. Okay. And again, don't lose the beans, because if you lose the beans, it's going to throw off your mass. Okay. All right, my isotope C. Very carefully. Okay, isotope C, I got 10.63. And lastly, you got to be very careful about this. I was not careful. Oh no, the beans are everywhere. Oh no. I got some under my scale too. That's not good. There's one. Okay. All right, back to what I was doing. Remember, always make sure that your scale is reading 0 before you try and make any measurements. Otherwise, it's not going to come out right. Okay, isotope D. Oop, lost a couple. Here we go. Okay, isotope D, 10.02. Okay, so I've got all my masses. Now let's check what we're doing next. Let's see, that was step 3. Step 4, count how many particles of each isotope there are, meaning count how many beans you've got of each type. Okay, so I've already got D right here, so let's go ahead and count it up. Okay, just take them off carefully. Oh, that was bad. Okay. Let's see. It's 10 right there. $20, 30, 40, 47. Okay, so for my number of atoms, I'm looking at isotope D right now. Okay, this is isotope D. I've got 47. So it's critical that your mass and your number of atoms come from the exact same isotope, or your numbers are going to be wrong. Okay. Now you'll notice that once I typed in this 47, here I'll do it again. Once I typed in this 47, a bunch of these calculations started filling out. All the white boxes are calculations that are already set up for you. Okay. All you have to do is worry about filling out the green boxes. Okay. So next, I'm going to count isotope C. So we're going to repeat the same process. Okay. Okay. So 3, 6, there's 10, 5, 8, 10, there's 20, 30, 40, 52. I count 52. So next to isotope C, I'm going to put 52 for the number of atoms. Okay, let's count isotope B. Okay, isotope B, I've got 3, 6, 9, 12, 15, 18 of those. Okay. And then for isotope A, I've got 2, 4, 6, 7. So I'm going to enter a 7. Okay, now that I've entered everything in the green boxes, you'll see all of these white boxes are now filled out. And this entire table matches a table on your Beanium Lab worksheet. So you're going to copy all of this data into that table. Okay. And what you're really looking for is this number right here. Okay. This 0.30 is my atomic mass of Beanium for this sample. Okay. I made sure to label it for you so that way you guys know exactly what you're looking at. Okay. Once you have completed this, okay, once you have done this for one sample, you're going to take your sample, okay, carefully without spilling or losing any of the beans, okay, and you're going to put it back in the container, okay. Just carefully put it back in. Make sure I didn't lose any of the scale. Nope. Okay. I've got my sample right here. Okay. That was one I just did. Now, once you've done one sample, you're going to return that one and get a new sample, a second sample. And you're going to repeat this process and you're going to enter the data in your sample number 2 table. Once you have both tables filled out and copied into your worksheet, you're going to talk to your instructor and you are going to give them your data, which is going to get plugged in right here in the spreadsheet, and it's going to come up with a class average atomic mass. Okay, so we're going to collaborate and everybody's data is going to go together and we're going to come up with a class average atomic mass, which would be similar to the mass that you would find if Beanium is listed on the periodic table. Okay, once you've completed all that, answer the post-lab questions and that'll be it. Okay, so if you have any further questions, don't hesitate to come talk to me about it. And I'm looking forward to doing this lab with you. Until next time, see ya.